Can you hear me? Okay, thank you. One request, if people start talking in Twitter about whether I'm talking too fast or swallowing my consonants, please just say something and I'll try to speak out. I'm going to be talking about...
Oh, you have done something with...
Oh, I'm sorry. I seem to have lost my screen.
You should do Miro displays or something like that.
Let me keep that in mind.
Yeah, Miro. Yeah.
Okay, good. Sorry about that.
Click on the dialog box saying that you want to have Miro, otherwise it will just...
I think that I got that now. Oh, okay, yes, yeah, I've got it. Okay, got it. Thank you. Take two. I'm going to be talking about a language called RESTful API Description Language. We've been using this at EMC Corporation with the REST Governance Board. That's a group that I chair. And our job is to teach people how to do REST, to do reviews of people's proposed REST interfaces, to make sure that we're doing REST in the same way. And we have been going nuts with some of the tools that already exist and the lack of the tools that we want. So we decided to develop something that met some of our needs. This has changed quite a bit from something that was presented at Malasage. We decided that the way we were doing it back then had some flaws. REST has a basic problem that Roy Fielding described this wonderful architecture that everybody adopted, at least in their minds, but he didn't tell us how to design REST APIs. We also didn't get a lot of tools that really followed his architecture in terms of API development. So you can understand the REST architecture very well and still not know how to do a REST API. This has been really frustrating for our developers because what happens is they go out there, they Google how do you do REST API design, they find different answers, they read different books. One of our experts recommends one REST book, one recommends another REST book. They both seem to be purist REST. They disagree on exactly what you want to do. Then they go looking for tools, and the tools don't support the kind of development that we've told them they're supposed to do. So basically, we tell them, go do pure REST APIs, and they say, well, what do you mean? What are we supposed to do? They're a little bit baffled. They also need to create documentation and runtime metadata. They also need ways to make sure that their implementation matches their specification, the kind of thing that Waddle does, but Waddle isn't really RESTful. Roy Fielding got really frustrated with the number of APIs calling themselves RESTful. He wrote a variety of blog posts. Here's one of them. He says that RESTful APIs must be hypertext driven. We're at an XML conference. We understand hypertext. We think that we're experts on this. We're the kind of people who understand what it means to have structured documents with links in them, right? Roy Fielding says, I'm getting frustrated by the number of people calling any HTTP-based interface a REST API. If the engine of application state, and hence the API is not being driven by hypertext, then it cannot be RESTful, and it cannot be a REST API, period. But most REST APIs are something that is now frequently called pragmatic REST. I use quotes because, first off, the guy who invented REST asked people to please not call this REST. And I think it's very confusing. But Corey House wrote a great blog post called How RESTful is Your API? He's actually a fan of pragmatic REST, but he's also very clear about what the differences are and what the advantages are each way. He says, if you see a REST that claims to be RESTful, what it's really doing is saying, here's a bunch of URIs. I'm going to tell you which methods to apply to each of these URIs and what the conventions are for applying methods to those URIs. Okay? That's not necessarily bad. Those kinds of APIs work. There's good tooling for those kinds of APIs. They're not REST APIs. And they're not what we're trying to do at EMC. RESTful APIs must be hypertext driven. Okay, what that means is servers send the state of a client to the client in the form of hypertext. The links in that hypertext tell the client what they can do. And the way that a client knows how to use those links is they know what kind of document they're looking at, what media type that document belongs to, and what the conventions are for that link in that particular media type. In other words, what the media type description should tell you is what you can do with the links in the document, how you can move from one state to another. And that's not what most of them do. I'll show you a little bit of that in a little while. To give you an idea what a hypertext-driven API looks like, well, as human beings, we do this all the time, not as computers, but we look at web pages and we say, okay, let me read this thing, let me find a link, and based on what I understand of this particular media type, I know how to use those links, right? Now, what does that look like in hypertext? Here's an XML representation of a documented repository. And you see that in this repository, I can look at my users, my current user, my groups, my cabinets, my formats, my network locations. There's various things that are identified by link relations. You see the rel equals here. They can also be identified by a path or a name of a link element, but link relations are a preferred way of doing it. Your REST client is supposed to use the rels to identify the links. They're not supposed to know anything about the URI and the href except that they can use it. There's an exception to that that's called URI templates. If you know what that means, you now know that I know that it's an exception, but I'm not going to go into that right now. Now, you can also do the same thing, JSON. You see here that I'm identifying link relations with a rel property, and then there's an href that identifies the URI that's associated with that. So what a REST client does is it reads the document, it finds the links, based on its knowledge, provided either to the developer reading ahead of time, that's what happens most of the time, or via runtime metadata, it uses those links. And the advantage of this is that it means that you're loosely coupled. It means that your clients and your server implementations can develop independently. On the cloud, it means that you can direct your links to different servers in order to balance your load. There's a variety of things that you can do that really basically mean that everybody can develop their server stuff without worrying too much about breaking clients. It's also very simple to write clients this way. So how do we make our tools RESTful? Well, first off, let's recognize that most tools are for pragmatic REST, not for real REST. And that starts actually with your JAX-RS annotations. Here's a tutorial, like many other tutorials, that shows how to use JAX-RS annotations. And here, he actually goes as far as telling you the media type that's associated with a GET. So you can say what the media type is with these annotations. You cannot say here's the document that you're going to get in this media type. Here's the links that you're going to get. We've considered whether you should even be able to say that some links are required, some are optional, things like that. We haven't quite gone that far yet. But basically, what it does not tell you is exactly what a client needs to know. How do I find the links? What can I do with the links? Starting with the annotations, that then filters up through the tools. So here's a storage service described in Waddle. This isn't about media types or links. This is about something called resources. Resources are identified by hard-coded URI paths. There's not a link relation in the document. This is not designed to do what a REST API should do. There's a reason for this. This is the stuff you need to know when you're writing an implementation. And it's good to know what to do when you're writing an implementation. We do need that information too, but that's not what a client should be looking at. Clients knowing too much about the implementation is where type coupling comes from. Here's a Swagger document. Again, you've got fixed URIs and the operations that can be applied to it and the conventions for those operations. So that's exactly what we don't want to do. What do we want to do? We want to provide a user view of a REST API. In addition to that, we want to be able to provide the information that an implementation needs in order to implement that same thing, and have the implementation and the client get information that's consistent. The user's view includes media types. Within the media types, we have documents. These documents have links that are identified by link relations. If I know what document I have and what media type I have, that identifies the interface. In other words, that identifies the interface, which is the conventions for using that link. Let me say that one more time. The interface, which is the conventions for using that link in that context. Those conventions can use things like URI parameters, headers. There may be authentication that's needed. Here's an example of what our generated documentation looks like. Here I have a maps service. It's composed of a set of media types. In this case, I'm simply extending the XHTML media type, and I'm using the ping. I'm adding semantics using microformats that are embedded within the HTML. So you can either extend existing media types or else create your own. If I look at any of these documents, you'll see that I have a link relation, the methods that can be applied to it, then I have the conventions for the request and the conventions for the response. Either the request or the response can identify documents. You may be putting or posting, or you may be getting a document. And obviously I can go to the different documents. I can click around here and see what's going on. One particular document is known as the home document. And that is, if I know the initial URI for the service, where does it bring me? Then I have my link relations, which are used in the interfaces. And I have my URI parameters that are used in the interfaces. What I don't have to know about is what the URIs are, what the resources are. Okay, those things are server implementation details that the client does not need to know. Now let's start looking at the things that the server and the client need to agree on. These are the interfaces. Interfaces can be local to a link, or they can be shared in a media type. The interface basically says that for this link relation, if I do a get, my request is going to have these conventions. So it might have a set of URI parameters. My response is going to have these conventions. It might use some headers. It might have a document type. In addition to interfaces, there's something that is not shared with the client at all, which is the resources. What a resource does is it associates a URI or a URI template with one or more interfaces. Now, if you think about this in terms of how you implement these things, the tools for Java, RS annotations, and things like that are all based on the URI. The server needs to know the URI. Everything on the server side works with that. So what this basically does is it makes it easy to implement what we've specified and told the client about. Okay, I'm going to look at two sample Rattle documents if I have time. And actually, given my proclivities, I might be better off doing this in Emacs. This is the document that we were just looking at, the maps document. The documentation element allows me to import an XML vocabulary. It can be an HTML vocabulary. We've implemented this for DocBook and for HTML for our own use. I can have documentation elements at various levels. One of the great things about using XML for this is that you want to be able to use things like tables and images and other kinds of things that are used to describe things in a documenty kind of way. You wouldn't want to write this stuff in JSON. Then I have an optional start element. The start element tells you what your initial document is going to be. I have link relations and the documentation for them. Then I have my media types. My media types have the documents that can be served. And my links here are going to identify interfaces. My interfaces have things like URI parameters and headers and things like that. And they say, if I apply this method to this link, what are the conventions? Okay. I'm not going to go into great detail here because of time, but I think you get the idea. And here are the resources that associate these things with the URIs. I think I'm not going to go into this other one because I want to leave some time for questions. What we've done so far is we've taken a precursor to this and we've used it to teach REST design to people at EMC. We found it very useful in a couple of ways. You can be talking with somebody and you can write down the design quickly and show them the design. You've got a notation for thinking about this, right? We're XML people, we understand this. Having a model helps you think more clearly. Having a notation helps you think within that model. And designing the notation makes sure that you've got a clear way of thinking within that model. This gives us the tool for generating the HTML documentation. We found this very successful. I've talked to a couple of groups that were stuck, didn't know how to get their design done, and within a fairly short period of time, we're able to help them get started knowing how to design REST APIs. We've generated HTML documentation really just on a test basis for some of our APIs using this, and we're pretty happy with the way that it looks out. We haven't yet put this into production. We're at very early phases with this version of Rattle. We've made some significant changes in order to make it more RESTful. And there's a bunch of things that we need to do next. The first thing is we need to move from having a model to having a methodology. And by that, I'm using methodology with a small m, but what I mean is that the model is enough for me to think clearly and work with other people to where they know how to do this. A methodology is something where I can write down how other people should do it, and they don't need me there in order to do it. We need to have Java tooling using REST annotations. Java is probably the language for which this matters the most in our implementations. The nice thing about Java RS is because you generate the documentation from your implementation, you know that it corresponds to the implementation. A lot of that we can do with existing annotations. We may need to extend the annotations in order to do that. But we want to make sure that we can guarantee that the specification and the implementation correspond. And we're also working on how you serve up runtime metadata in JSON, XML, and in HTML. HTML for human beings, JSON for, it's easier to program with, XML for geeks like us. And part of that is making the metadata more granular as it's served up. Okay, I'm done. Any questions about this?
So there will be a question from Mohammed, right? Or maybe Michael has microphone, so we can start with Michael, please.
Is it possible to explain in a sentence or two what hypertext-driven means as Roy Fielding uses it, or does that involve attending a re-education camp?
That depends whether you want to get it by reading Roy Fielding or whether you ask me, I think. I feel like we spent a lot of time reverse engineering things that he'd written down. I think what he means by hypertext driven is exactly what I said about the server provides the choices in the form of links. And there's one quote that is probably best to start with here. I'll pull this up on the screen and then try to deconstruct it. It's this paragraph here. A REST API should be entered with no prior knowledge. Now let me put this in plain English. All a REST client knows is the initial URI and the media type. Knowing the media type means that the client knows how to find links and what they can do with the links once they find them.
That's where I drop down. I can understand a human understanding the difference between to book this itinerary, click here, to cancel and ask for a new itinerary, click here, but I have a hard time understanding how software is going to do that without before artificial intelligence people have finished delivering HAL.
You're making an assumption that I'm not claiming. So I'm not necessarily believing that software is going to automatically find this stuff out. We nevertheless do want to provide the metadata so that if there were software that's that smart, we can provide that structured information in the form of runtime metadata. So RADL is a vocabulary. If you understand that RADL vocabulary, then you can understand what this information means. And if you write software that's smart enough to use that, it can at least discover it.
Okay, so interacting with this requires no prior knowledge except the initial URI, the set of standardized media types, and some natural language in which the rest of the information is expressed.
Yes, I believe that the vast majority of people actually programmers usually write the software understanding what the media type is. That's the way the world works now. We also very much want to serve up the metadata where what you need to understand is the language that describes the metadata, and then software that's smart enough to leverage that automatically can do so. That's
Okay.
one of the next steps that now, how far software is going to actually go with that, I don't know. We've had grand visions about that that haven't really been realized in the past.
Thank you.
So, Mohammed?
Yeah, reading the title of your presentation and knowing your background, I'm a bit surprised that you didn't relate it to xQuery in some sense and to xQuery to REST-XQ API. So, is it in completely different world, or has it something to be related in some sense, and if this, how?
I'm sorry, I could not hear what you said very
Sorry.
clearly.
Okay,
I'm
I'll
sorry.
start again. I say, reading the title of your presentation and knowing your background with xQuery, I was surprised that there are no mention of xQuery at all in your presentation, first. Second, how does it relate to an xQuery attempt to do this kind of thing, which is called REST-XQ? How does it relate?
Okay. So first off, this has no direct relationship to xQuery. It's orthogonal to xQuery. The way that you implement a service is completely hidden to the client and should be in a REST API. Now, if you use something like Adam Rutter's annotations for xQuery, remember how I said that I thought that in the Java world we ought to be able to work with Java annotations to, and by that I mean to make sure that something corresponds to the specification, or also to generate this information from the implementation. I think that would be easy to do with Adam's RESTful annotations that allow you to implement RESTful services using an xQuery. And yeah, that would be a great tool to have.
Okay, so it's direct relation. We can do this. You said on Java, and we need to do Java, but we could do the same server-wise with REST-XQ.
Yes, absolutely.
Okay.
Okay. Any other questions, comments? I think. Okay, then thank you. Thank you, Jonathan.